Will you come live with me and design everything in my house?
Yeah, but yes, let's do it.
This is StarTalk, Sports Edition. Neil deGrasse Tyson here, your personal astrophysicist. Let me introduce my co-host, Chuck Nice. Chuck.
Hey, what's happening?
And I got Gary O'Reilly. Gary, former soccer pro.
Hi, Neil.
All right, dude. And also sports announcer. And
yes.
So Gary, you cooked up this episode, so I can't wait to find out what's going to happen.
So this show is about smart engineering, right? Innovative material science, kick-ass sportswear design, all converging, as I said, to help people recover faster and live longer. The link
Recover from sports injuries, I guess.
Patience.
Spoke too soon.
Yes.
Sorry. Okay.
All right. The link to all the above is sadly diabetes.
Ooh.
Wow.
So we are trapped, or are we, in a failing endocrine system? The results are only amputations, or is there a way to walk out of this particular hell? Let me introduce our two guests.
I see what you did there.
Yeah, but I saw
Thank you
that
kindly.
too.
Yeah,
Very good.
we caught that, Gary.
That was
we
good,
caught
Gary.
that.
I know.
Yeah.
It won't happen again. So Dr. Jason Hanft, the person that chose to question why things were not improving with his patients' conditions and then investigated. He is a foot and ankle surgeon and clinical podiatrist in Miami, Florida. This is the guy who had the gonads to then go out and do something about it. Let me then introduce our second guest, an industrial designer, Michael DiTullo, with a client list that has included Google, Nike, Jordan, that'll be the Michael version, and Honda, as well as having been the design director at the sportswear giant Converse, winner of the Industrial Design Society of America Personal Recognition Award in 2019. So, Neil, please welcome our two guests, the good Dr. Jason and Michael.
Well, excellent. Welcome to StarTalk, guys. My gosh.
Thank you for having us.
Yeah. So let me start out by saying, could you just remind us why diabetes has anything at all to do with like circulation, which ultimately ends up in amputations? Because we hear that it has to do with, your metabolism and processing of sugar, and then all of a sudden somebody gets their legs amputated. Like what? How do you get from here to there?
Let's take a half a step back. Let's talk about who gets from here to there. So as of today, 1 in 10 Americans is diabetic.
Ouch.
By 2025, it's going to be 1 in 3.
In
two out of
3
10
years?
In 3 years?
In 3?
What?
Correct.
Wow. And 2 out of those 3 will be black.
No, that's Chuck. Okay.
So that is not an
Wow.
understatement.
Right, okay.
People of color and people, Native Americans, have a 50% higher chance of becoming diabetic.
Oh, my.
Wow.
So if you're looking at, hundreds of millions of people around the world becoming diabetic,
Yeah.
once they've had diabetes, the fluctuations in blood sugar affect the myelin, the covering of the nerves. And the nerves that are farthest from your central nervous system, your brain, have the longest amount of myelin. So this tissue, because of fluctuations in blood sugar, gets thicker and thicker, and the electrical impulse cannot be conducted. So they develop what's called peripheral neuropathy, loss of feeling in the hands and feet. And this isn't if you step on a nail, you can't feel it. This is small amounts of pressure you can't feel. So here you have this large group of people who lose the feeling in their feet, and they get small amounts of pressure over time. A shoe rubbing, a sock balled up, an inappropriate fitting shoe. This cuts off the local circulation, leading to a wound. Of all the wounds that occur in the US, roughly 3 million a year, 85% of those will become infected within 6 weeks. That's the pathway to amputation.
Wow.
Is once you violate the tissue envelope of a diabetic patient, bacteria get in, and that's the pathway to these 120,000 plus amputations a year.
So Jason, specifically, what are the most common symptoms?
Typically, they have no symptoms because they have no feeling.
Oh,
so
jeez.
My
That's
God.
what I was going to ask.
Oh,
because
man.
I read that the myelin is like a conductor. It allows the electrical impulses to run, travel up your spinal cord and whatever. So if that stops or slows down, you're not feeling anything then.
Correct. So typically the only time that people present with a wound is when someone visualizes it. They don't know they have it until they either look, which most people can't see the bottom of their foot, or someone else looks at their foot.
Is this nerve damage repairable? Or is this just
right now-
one-way street?
Right now, there's no cure for diabetic peripheral neuropathy. There are adjuvant therapies, vitamins, etc., and there are medicines to manage the symptoms, but there is nothing to bring back the feeling.
Wow.
Medical science throws a lot of resources at a number of problems. Has it thrown the resources at this particular condition, or is this condition just particularly baffling right now?
It's quite baffling. Resources in the billions have been thrown at it, including genetic modifications, gene therapy, oral medicines, injectable medicines, tissue transplants, and to date, nothing has worked.
Wow. Well, that's our show, people. Thanks so much.
We're done. Okay, so allow me to dare such a suggestion that your only solution is for diabetes to go away.
So curing diabetes doesn't cure neuropathy, even if you have patients who have peripheral neuropathy.
No. I'm saying no. I'm saying preventing diabetes in the first place, eradicating it from the species, puts you out of business. Is that correct?
Oh, please. Yes, that would be wonderful.
Okay. There you go. That's all I'm trying to say here. That we can try to keep putting Band-Aids on a problem when the problem perhaps should be solved in a different way, rather than bring out all the Band-Aids and the hacksaw for your amputations. I mean, that's all I'm saying. I'm just making a simple point.
See, and that's the difference between a truly caring medical professional and capitalism. Because the real answer is no, Neil. We don't want to cure it. We just want to find a way.
We want to keep treating it. Yes.
Right.
Yeah.
We want to
There's
find
no
a way
money in the cure.
There's no money in the cure.
No, only in the treatment.
I must ask, from a patient walking into your clinic, and with the fact they're aware they have a diabetic ulcer, and things go wrong, what is the timeline? I know you said it could be 6 weeks and an infection. So what then is a timeline to amputation? And then what after amputation are we talking about for their future, if there is going to be one, and how long are we talking about?
So this would be, just to be clear, this would be an ulcer in one of your extremities that would go unnoticed and then gets infected.
Mm-hmm.
Yeah.
So
Okay.
this is an ulcer in the foot, typically, because the hand amputation rate is 100 times less than the foot amputation rate, because you don't walk on your hand and you can see them.
Yeah.
The real issue is the pressure of walking, right? Once you get a hole, the pressure of walking keeps the wound from healing. It doesn't allow the body's healing processes or even external healing processes to take place. 7 to 26 times your body weight goes on the bottom of your foot with every step. So if you're trying to heal a wound and you can't take the pressure off, low likelihood. So to answer your question about timing, it depends. The extent of when the infection is identified, right? If you're at home, you don't know you have a wound, you're not looking at your foot. If this infection is spread to the bone, there's a very high likelihood, north of 70%, that you'll end up losing a portion and or all of your foot.
Doesn't the body respond to infection with a fever? And wouldn't that be a noticeable symptom?
So in the non-diabetic or healthy, non-immunocompromised patient, fever, redness, swelling, pain are the signs of infection. But the diabetic patient is considered immunocompromised, and they don't mount the same type of response. So it frequently goes unnoticed.
Dr. Jason, how many of your patients would you clinically identify as obese? Because that means that I may not be able to see my feet. I have been compounding, literally, the pressure and weight through my lower limbs. And it's built almost in a perfect way to end in a destructive process.
I mean, the perfect storm, you're saying.
Yeah.
Because if you're morbidly obese or obese in almost on any category, you don't really see the lower half of your body at all, right?
Yeah.
So this is absolutely correct. There are two types of diabetes, type 1 and type 2. Type 2 is by the vast majority. People are overweight, increased BMI. So then not only can't they feel the bottom of their feet, they can't see them. And unfortunately, this is one of the pillars of why this epidemic has not only expanded and continues to grow, but has gone sort of a shameful mark has been put on it, right? Because people who are heavy have this.
So let me ask you this: since there's no symptoms, we also know that you're at risk if you are obese. Is there any preventative self-diagnostic tools that you might be able to use to say, hey, I'm in this risk category now. Let me keep an eye on this?
A foot mirror.
Well, that is the simplest answer. Absolutely correct. With new technologies, with Bluetooth-enabled maps, temperature sensing maps, visualization and temperature measurement can be done remotely. So you can have a mat at the foot of your bed every night. You stand on it. It can measure temperature, pressure, and report to a cloud where a medical practitioner can follow up on that. So there's absolutely technology available to assist. But in the simplest format, a mirror on a stick or a spouse inspecting your feet daily. And the American Diabetes Association recommends regular routine visual inspection of the foot.
Wow, look at that.
Low tech and high tech.
Low tech and high tech, yeah. I was going to say it'd be great if, as a part of your regular medical insurance, you'll be able to get some of those technological assistance. But then you said mirror on a stick, it's over. That's what you get. You're like, I'd like to avail myself of some cloud technology. They're like, here's a mirror on a stick.
So I think, Chuck, it's anything on a stick. That's what it is. That's the real indication.
There you go.
We got nothing left for you.
We got nothing left for you.
So, Jason, we're getting into a medical universe now that has brain-machine interfaces. And that work and development, would that be of any use to this peripheral neuropathy?
So you can stimulate the central nervous system and you can interface with the central nervous system and trigger it. But when the wire leaving the junction box isn't working properly, nothing goes any farther than where that myelin has been thickened.
Right. It's like a jamming signal. That's crazy.
Wow, yeah.
That's an accurate description.
Yeah.
Is there a potential chemical solution once it thickens to reduce that?
There are a number of companies that have tried. To date, nothing has been successful in clinical trials. The best way to keep your myelin thin is to keep your blood sugar under control. So if you don't have these massive swings of blood sugar, the myelin doesn't get thick. And there's lots of technology for assisting in keeping your blood sugar under control. Continuous glucose monitoring, pumps that instill medications, Wi-Fi communication to phones, vibrating headsets. I mean, there's all sorts of devices available out there to help you control your sugar.
All right, guys, we got to take a short break. When we come back, we're going to find out why Michael DiTullo is actually one of our guests, as well as Jason Hanft on StarTalk. We're back, StarTalk Sports Edition. We're talking about your lower extremities, right? Your feet and boots that might be worn over them. And we got with us two guests, Dr. Jason Hanft, and we bring on in this segment, in full force, Michael DiTullo. Michael, you came in on the other side of this. What's your role and what's going on here? How are you trying to make this a better world?
Thanks, Neil. My background is as an industrial designer. Most people listening probably don't know what an industrial designer is.
I know what it is, and you guys are my favorite people in the world.
Thank you.
Oh, my gosh. It makes living not only helpful, but beautiful. And so thank you.
Chuck, we're going to leave Michael and Neil to get on.
Yeah,
There's a love.
I was about to say I'm going to have to turn my camera off for a minute. I thought I was Neil's favorite person in the world. I'm like, damn.
No.
This is terrible news. I just found out.
No, it'd be like
Neil and
Rodney
I,
Dangerfield says, "Hey, get a room." You know.
Yeah, I'm gonna make a Zoom breakout room for Neil and I, so the rest of you guys can. But no. So I explained to people, like, if you think of what an architect does for buildings and what a fashion designer does for apparel, I do that for literally everything else in your life. Your phone, your pen, your car, your chair. For better or for worse, everything you touch was designed by an industrial designer at some point. And so for me, I love working on challenges. I love learning. I always say I'm not a subject matter expert. I'm a creative generalist. So I love partnering with people like Jason, who are super passionate and crazy knowledgeable, because I feel like I could pull out of them some crazy parameters that we can use to find an innovative solution. And in most cases, I mean, when design is like this fun mix of science and art. And I think when you're putting these two things together, the right solution oftentimes afterwards seems painfully obvious, but it's only until you get to that it seems that way, if that makes sense.
Yeah, things like a paper clip. I mean, there were no paper clips before somebody invented a paper clip.
Exactly.
And so that's probably in the Hall of Fame of industrial design. Among things. So all right. So let's take a sample case. 400-pound person with diabetes walks in, and Jason has a look, and you have a look at this person. Now, how do you put your heads together and address what's going on here?
Well, when Jason came to me about 4 years ago, the first thing we did was put together 3 basic principles. One, it has to functionally perform, obviously.
But the it is a what?
You're right. So we wanted to create this protective boot, right, that would create an environment where someone's wound could heal, right? Because if you're walking, right, if you're a normal person, you're going to still go to work, you're going to still go to the grocery store. So you can't avoid putting pressure on your foot. So we have to create an environment that alleviates the pressure so that someone's wound can actually heal. So that's principle 1, has to function. Principle 2, it has to be easy to put on and take off, because again, we're dealing with a person with reduced mobility, reduced feeling, right? So they have to be able to put it on and off error-free, even at 2 a.m. when they have to run to the bathroom real quick.
And I'm going to channel Chuck here, and it has to look fabulous.
You better.
Well, that's the third principle.
There you go.
The third principle is it couldn't work if it stays in someone's closet, right? Because if they feel too ashamed to go to work in it, it can't work, right? It will fail 100% of the time that it's not used.
And listen, you know how many people need orthopedic shoes, but they will not wear them?
Right.
Yeah.
They're like,
point.
no, I refuse.
That is exactly what was going on here before, Chuck. The devices that were on the market, there are other boots to protect the foot, but people couldn't or wouldn't use them, all because of that appeal. They were not usable or good looking.
Right.
My goal is, if you put this on with a pair of jeans, it's going to look as much like a pair of Jordans as we can make it. So that instead of someone saying like, "Oh, what's that?" I want someone to say, "Oh, what is that?" Tell me about that.
Very good.
Right.
So, okay, you mentioned Jordans.
More importantly, you want them to say, "Who is that?"
No.
Oh dear, my! Those are. Who is that?
Who is wearing those? Who are you wearing?
All right.
Yeah.
So
What's crazy is that we're building this out for function, right? But the world of fashion, you look at like what Kanye West is doing with Adidas. It's not far off from where this is going. Where a $600, $800 pair of Balenciagas is. So we're kind of like, these worlds are kind of colliding right now.
all right, Michael, you mentioned Jordan, so we'll bring up the GOAT, if you wish, and I do. You designing specifically for Michael Jordan, right? Back in your day. Now,
wait a minute. Michael Jordan has diabetes?
Do behave.
Oh, come on. That was good.
I know it was, but I don't want to give you any credit. I don't want to give you any credit.
Okay.
Sorry, Gary. Sorry. Go
No,
ahead.
that's okay, man. So everything you've designed for him and every other elite world-class athlete has a rise, and you are pushing the foot forward so as the weight goes through the ball of the foot so as I can sprint, or maybe in this case, Michael rather than me.
Yeah.
So you offset the heel. It's not a level flat. So think of a skater's sneaker. It's flat to sit on a skateboard, right?
Right.
When you've got a sneaker that's like a basketball sneaker or a running shoe, it's raised. The heel is raised. You've got to drop. That's putting pressure on the ball of the foot for a reason so as you can launch forward. Now, everything you've learned to make that for those athletes, you have to kind of pull apart. So how do you start to do the retrofit? Because you can't put the pressure through the ball of the foot, surely.
Yeah, that's exactly right. This is the Jordan 22 PE that I worked on. This has got a 10 millimeter drop, from the heel to the toe. A running shoe might have even more. That's pretty common, right? They're anatomically like forcing you onto the balls of your feet, which are exactly where the wounds from a diabetic foot ulcer are. They're typically on the balls of your feet. So that's aggravating those diabetic foot ulcers. And as Jason said, most folks who are getting treatment, they're leaving the office in their shoe. So they're leaving the office in the product that's aggravating their wound. So this product that Jason and I worked on, the Foot Defender, has a slight negative 2 millimeter heel drop. It deceptively looks like a footwear materials, but underneath this is a injection molded brace that goes all the way around the product. And then we've got a piece of sprung carbon fiber here. So that is really forcing the geometry of your leg backwards. So you just cannot put pressure on it. The bottom is also flat. So unlike a sneaker, right, where you have these huge rockers kind of leading you into and out of the product, by being flat, again, you can't get out over onto the balls of the feet. So there's so much kind of geometry and science that goes into this thing that deceptively looks a lot like a shoe.
That's amazing.
We developed
Michael,
it for. Go ahead.
Michael,
go ahead,
I'm
Chuck.
sorry to cut you off here because first of all, ingenious design. Secondly, love the form and function playing together. Thirdly, and most importantly, how do you get me Jordans?
It's just one.
Just got
Anyone else know that
like
was
everyone
coming?
else.
just come visit me in Portland, Chuck. We'll take care of you. Yeah, I'm not that far from campus.
So, okay, Michael, you've conquered the bit where the foot must move but remain rigid. You've redistributed the weight.
Yeah.
But in doing that, are you then the blessing and the curse? Are you then creating other mysteries that you need to solve in this particular solution?
I'm gonna let Jason take that.
So the answer to your question is yes, but that's where 35 years of biomechanical analysis comes into play. So if you look at the foot really carefully, the mid part of the foot is a rigid arch. It rarely, if ever, touches the ground, and it doesn't move. So you now have a structure by which you can transfer force to without causing a problem.
Nice.
And
Good
this is part of
detective
the
work.
reason. Well, this is part of the reason it took 7 years and 39 iterations to get to the device you're seeing today. Whereas once we, force doesn't disappear. Neil can appreciate that. But once you move force from one place to another, you have to come up with a mechanism by which to deal with it, whether you're decreasing it by creating unique materials, viscoelastic materials that rebound and push it in another direction, or you use very rigid materials to transfer it up the leg.
Right. So, because you're not making this out of just one supply of rubber or plastic.
Right.
Were there commercially available materials to do this, or did you have to be creative beyond that?
So there were some in the footwear world. We used a number of materials that you would find in the footwear world, wicking, anti-friction, foams, and cloth materials, textiles. But we were looking for maximum impact attenuation, right? So you have a 400-pound person whose muscles don't work and nerves don't work, so their foot's slapping the ground.
All right.
Much like you take your hand and just slam it on the table. So we looked at 700 different materials to try and find the best impact reducing material around. And we then modified it. So we essentially created a new material. It's a viscoelastic polyurethane that we are calling absorbium, that has
I love it.
Wow. Look at that. That sounds like something you find in Wakanda.
No,
Yes.
absorbium. It's next to
Absorbium.
the
Right, it's right. You find it right next to vibranium.
Yeah,
There
and
you go.
unobtainium is in the
And
same column.
unobtainium, exactly. So it removes somewhere between 87 and 90% of the impact force,
Wow.
just by the mechanical and material properties.
Wait, just to
Okay,
be
I hate
just to
to
be
say this, but
precise,
go ahead.
just to be physics precise, I would say, but tell me if I'm wrong, that it dissipates the force rather than
You are
removes it.
absolutely on point.
Okay.
Sends it
Just one.
someplace else.
Yeah. Sure.
But here's the thing. Now, guys, please don't judge me for this. It's just how I think.
We do anyway, Chuck. So don't worry.
Okay,
about it.
good. All right. So you're talking about something that is probably, the most prolific shock absorber for the foot in history. There's a crap load of money in running shoes for something like this. I mean, are you thinking about that? Maybe.
Well, in some ways, it actually does the opposite, right? So in a running shoe, you want the foam to rebound really quickly, right? You want that force return.
You don't want to lose the energy you
So
put coming
this
down.
is a
Exactly.
dampener. So
Right.
you want a return of energy if you're running.
Right.
Shock absorber. Yeah,
This
there it is.
right. So this takes. I got it. There you go.
Yeah,
And by the way,
and
Chuck, that's
that's
why
why
the
we had-
blade works so well, because all the energy that you used to land on it
Oh, the
is
prosthetic.
recovered when the thing
Right.
springs back.
Right.
Gotcha.
Exactly.
So yeah, that's a very different utility. Cool.
Michael, if we disassembled this Defender boot, how many pieces are there? So, like you do in an engine, the classic, take the engine apart and you lay all the bits out on the table. How many pieces are in there? Because my guess
Yeah.
is this has a ridiculously large amount of pieces.
Yeah, it's probably over 100. I mean, there's just so many different things going on inside of this product. I mean, Jason talked about that absorbium material. I even just wanted to aesthetically give you the hint of where those are, right? We talked about the industrial designer's job to make it functional, but also I want to draw attention to that function. So there's those two pucks are under the heel and the forefoot here. So kind of visually telling that story.
All right, can you hold
there's
that
so
up
many-
again? Michael, can you hold that up again? See the sole of the shoe right there. The guys, if you're listening to this on the podcast, apologies. But
Yeah.
that's like a foot within a foot within a foot.
Right.
What's going on there? Because that you can't tell me that's just cosmetic because it's on the sole of the foot and won't get seen. So there must be a really good reason.
Well, it is. I'm trying to kind of basically draw the eye inward because we have a symmetrical product here, right? So it fits left and right. So that automatically makes it aesthetically a little off. But I'm trying to kind of fool the eye to make it feel slimmer, more acceptable. You'll notice like all this traction is kind of oversized because you're wearing this inside and outside, and I want kind of dirt and grime to kind of fall out as easily as possible, but give you this traction that's going to give you that kind of the grip you want. So we're actually using basically a cup sole technology. So this is like one giant piece of rubber that's very stiff. That's used in kind of 80s basketball shoes, skate shoes. It's heavier and stiffer than a typical outsole, but we want that rigidity, right? So we're making all these choices to have functional benefits. Even this little hint of these kind of red embroidered hits, right? They don't need to be there, but they tell you without you having to look at the manual, like this is how you get into and out of this thing.
It's called design.
It's called design, people. So
All right, so
By the way, I got to
functional design.
interject here. I got to interject for those who didn't otherwise think about this. I'm not talking to you, Michael, but Chuck or Gary.
all right.
One of the greatest contributions to this world that Apple Computer gifted us is not even the computer. It's the fact that they made it normal for you to open the package and operate something without ever looking at an instruction manual.
that's right. Intuitive.
They
design.
made that
Intuitive
commonplace.
design. Yeah.
Correct. And I remember growing up. Okay, here's this box. Where's the on switch? Open up the manual. Where's the on? Where's the this switch? What happens if it has this? If it makes this sound? It's 3 flashes of light. What do I do now? That we have people growing up that have never looked at an instruction manual because of that. I told you, Michael. Me and you are tight. Okay.
You get in a room,
Thank you.
period. You get
Thank
in a
you.
room.
No, and that was my goal with this, right? Like this person, they got a life to live. I don't want them to spend time reading a technical manual. I want them to just get this thing from their doctor and be able to put it on, kind of idiot proof. I hate that term, but you know, foolproof in terms of just putting it on correctly, and not have to read a manual and to be able to use it and heal.
So, Michael, the boot's open-toed, which is
Right.
great if you live in Florida all year round. But you're up there in a different latitude. It's cold, and your foot's cold. So how are we solving this problem with an
Yeah,
open-toed
Michael, not
boot?
everyone lives in Florida.
Very, very intentional, as you would have guessed, right? And Jason could speak to this more, but most of folks that have this condition, right, their foot might be not a normal size. There might be swelling. It might be wrapped in bandages. And Jason, do you want to speak to that from your professional?
Sure. So everybody that goes in a foot defender has an open wound. That wound requires a bandage. If you put a closed toe on it, you're now confining a space, and you'll more likely get a rub or an area of pressure, and it'll be self-defeating.
Right.
What we found in cold temperatures is people are using really high technology. It's called a sock. You put a cold weather sock, and even available are some thermally assisted socks, right? They have a battery that can warm.
Yeah,
the
I've seen
foot.
those. Very toasty.
Electric socks.
Yeah,
Correct.
they're totally toasty.
Okay.
So just so our audience and I can remember, Jason, you're based where? Where are you now?
South Florida, Miami.
Oh, you and Michael?
Portland, Oregon, opposite corner.
Oh, Portland, Oregon. Okay, got it. But it's never really sub-freezing in Portland, right? It's always just cold and dank.
Yeah, you get a little snow, but not much.
Yeah. Okay. So that's where the Miami connection is coming in. So you're in South Miami, Jason, right? Correct.
Correct.
Yeah. All right, let's take a quick break. When we come back, more on this sort of diabetic boot solution that might prevent amputations, which is something we would all want when StarTalk continues. We're back, StarTalk Sports Edition. We've got Dr. Jason Hanft and Michael DiTullo. Jason is a surgeon who unfortunately is confronted with having to amputate many a lower extremity from complications from diabetes, and Michael DiTullo is figuring out how to not make that happen. And we need more folks like this walking among us in the world. So let's just pick up the conversation with this boot. Are we to say here that if you have a sore that develops on the bottom of the feet from complications from diabetes, this boot will allow it to heal? And do diabetics heal the way non-diabetics do, like on the same time frame? And do they respond to the same topical medicines, this sort of thing?
Really interesting question. So the best way I can give you the answer to that is diabetics don't do anything the same as non-diabetics. But we do know that diabetics have the ability to heal because wounds elsewhere in their bodies don't lead to an amputation every 20 seconds. And that's in the United States. Every 20 seconds, someone in the US is losing their leg to the complication of a diabetic foot ulcer.
Wow.
That
is disturbing.
Yes.
It's something we don't talk about, right? It's like because like Jason said, there's this shame associated with it that someone feels like they're at fault. It's you hide your wound in your shoe, you don't show anybody. And so I think a big part of what we're trying to do is just get this out into the open and be like, hey, there's no shame in this, let's fix it.
I love that because, this is one of the diseases that we often refer to as a lifestyle malady. And so the moment you add lifestyle to the description of the problem, it makes it seem like, well, you did this to yourself. It's like lung cancer. People are far less likely to have compassion for a person with lung cancer. Like, oh, you shouldn't have smoked.
Yeah, if you did it to yourself.
It's
Interesting
terrible.
point. Interesting point.
So, Michael, maybe you can answer this. You would have traditionally gone to a medical device equipment manufacturer to do this, but you turned around because you weren't getting the results you wanted and went to a shoe factory. Am
That's
I right?
right.
And why?
Yeah.
What was not being delivered for you in the medical equipment
what was happening
manufacturer
there?
that you could get with a shoe factory?
We struggled for 2 years. We're working with some medical device makers to hit the performance targets, but we couldn't get the fit and finish that made it feel like an acceptable consumer product, that made it feel like you could get it at Foot Locker, to be short. And so finally we were having a brainstorm session in my studio, Jason and I was like, maybe we're just thinking about this totally wrong. We were working with a medical factory who were exposing all the hard plastic parts. And it just was a real challenge to make it look right. And then every time we wanted to make it change to tweak the performance, like massive tooling costs. I was like, let's start thinking about this less like a medical device and more like a technical shoe that has to do something. And I think we'll be able to train a footwear factory how to make something with our technical parameters a lot easier than it would be to train a medical factory how to sew something like this. So that's what led to hiding all of the technical parts. You could just see these little peaks of it. You could see a tiny peek into the carbon fiber here. We expose it subtly, but by hiding all of it, we could create this nice piece of footwear. And then as we were prototyping and testing all different internal braces, we could make all those changes internally until we got the spec exactly right, and then confirm that with the factory. And now we just check to make sure they're executing it exactly to the specification.
Will you come live with me and design everything in my house?
Yeah, but yes, let's do it.
Do you do it all? Will you do something as simple as like a Michael Graves teapot or something?
No. If you're a
I love
designer,
it.
everything in front of you is subject to your scrutiny.
Yeah.
Oh my gosh.
I did this watch, so
There's no escaping it. Mm-hmm.
Yeah.
So Michael, you've
curse.
incorporated a pump into this
Right.
boot, haven't you? Now, for those of us of a certain vintage, flashback to what was it? Late 80s, early 90s?
Yeah, 80s, totally.
With the
80s.
Reebok, you've gone Reebok retro with a high top pump.
Wait, let me just remind people. So was it Reebok? There was
Yes.
a pump
Yeah.
it up, where it was a high top sneaker.
Oh, that's
that,
right.
That had an airbag in it where you'd put on the sneaker, lace it up, but maybe it didn't fit perfectly in all places. So it had a pump on it, which filled the gaps with air so that your entire foot would be more smoothly,
snugly fit.
Was that the inspiration,
within the boot.
Michael? Were you
And it
following?
lasted like 6 months, I think.
Neil, you took my whole description from me, but yeah, you guys.
Oh, I'm sorry. I was just getting people up to speed so that we can now listen to you.
It's awesome. No, so Jason was like, "Hey, maybe we should put a pump in it to fill the gaps, right? Exactly like nobody's two legs are exactly the same.
Yeah.
Even though it fits great and performs well, there could be this feeling of gaps. So you fit it up and then you pump up the rest, and now you're basically just pushing the internal sleeve in constant contact with the body. So you get this proprioceptive effect that you feel much more secure.
So the air bladder would fill in where it needs to and not fill in where it can't.
But yes, because it's a totally custom fit, and then the bladder is basically shaped like a pair of lungs. So there's basically two chambers. It hovers over your heel, so you're kind of really locking the heel into place. So again, we don't want to cause any more injuries. So any kind of repetitive movement inside is a potential for more injuries. So
Okay, Chris Rock was the lead performer in a Saturday Night Live skit back when that Reebok sneaker was popular, and it was Thanksgiving dinner, and it was in the spirit of the pump of the Reebok. They now sold turkeys that you could pump up. So the turkey had a little pump, and you can make it bigger if you had more people coming for Thanksgiving. It was just look that one up on Google. You should be able to find it.
All right.
So the other important and functional part of the pump is not only fit, but you can imagine if you're trying to control forces and the heel is pistoning up and down as the person walks, because it's a rigid device. If you don't lock the heel in, you're going to load the front of the foot. So it's all about this decreasing the pressure on the front of the forces on the front of the foot, because that's where 88% of the wounds happen.
Wow.
So how widespread is this product right now?
It's available everywhere in the United States. We're shipping to other countries. We really had our first product launch in April commercially.
That's
Nice.
so
Congratulations.
so recent.
Congratulations.
Okay, I
you.
heard first product launch. You've learned lessons from this. Obviously, it's taken more than 5 minutes to bring it from a clean sheet of paper to this.
Yeah.
What is it? A Category 1 medical device. What lessons have you learned along the journey, and how have you applied those then to new products?
I don't think this show has enough time for all the lessons we've learned. Our entire team has learned lessons because we're doing things that no one's done before. Nobody has built a medical device for the lower extremity that is patient-centric, right? Everything we did is built so that a patient will want to use it, because if you had rocket boots and patients wouldn't wear them, what good are they? So
You've got rocket boots?
Not yet, but we'll get there.
Working on it.
Oh, by the way, not to beat a dead horse, but in the early days of the PC wars between IBM and Apple, Apple did not have much entry into the business world because IBM was already there, and Apple got great inroads into the art world. So then how's Apple going to reach the business world? So they had a commercial where there's an Apple PC, there was a Mac, and there was a early in the Mac, and then there's an IBM PC, and the two executives are looking at it, and they say, which one is more powerful, the Apple or the IBM PC? And then the person answers, the one that's more powerful is the one that people want to use. And there was a line of people waiting to use the Apple, the Mac.
I love that.
And there was like one person on the IBM PC. That's all it is. That's that whole principle. Are you using it, then it's useful.
We don't claim to be the perfect pressure reducing device, but we really are a pressure reducing device that people can easily get on and off. And one of the things we discovered along the way was Michael and I and some other engineers spent a long time on this front spat, the anterior brace that Michael showed you earlier, and how it almost auto closes. You pull off 3 tabs, open it like a book, and then you let go and it falls back on itself. So it's really easy to do. But what we found was patients, about the first 50 to be exact, 49 out of 50, adjusted it once, put it on and off like a cowboy boot. They just slid their foot in, slid it out. They leave it by their bed at night. They don't have to adjust anything. They just slide their foot right in. And the device isn't designed to fit skin tight. It's designed to fit. It's small, medium, and large. So that's also where the pump part comes in handy. So if you're in between sizes, it'll help. Right. But with the device on and adjusted appropriately, it doesn't have to hug you tight or reduce circulation.
Okay, so Michael, Jason just opened up a whole nother product line here, which is you make this out of ostrich skin and other common leathers of cowboy boots, and you can start a whole new style.
Oh man,
right? You know, a whole new market.
And alligator skin.
You're corner to the Texas market. That's
yeah. So the other learnings we found, and all of our business has been built on what patients have told us. We essentially polled 5,000 patients and said, why aren't you using the devices you have? And the first answer was, I can't. The second answer was this stigma, I can't go to work and do it. And the third one was, when I get home, I need to take my device off because it's dirty from being out in the world. So here are these people that are protecting their foot all day. They come home and they walk around in a sock or a flip-flop or a slide. And there's data out there that shows you actually walk more at home than you do at work for most people. So here they are all day being diligent. Then they come home and put their body weight times 7 or more on their foot all night long. So what the patients told us was they wanted something protective to use at home instead of socks or slides.
Okay. So Michael, you heard about that, and then what did you do?
Yeah, so I thought of if we could think of the Foot Defender as our F1 car, right? This is where we're going to do all our research.
F1
R&D.
Formula One car. Listen to you.
Yeah.
Oh my gosh.
Yes. So this is where we're doing all of our R&D, right? How can we take that down into the BMW M3 that someone could drive to work every day, right? So we developed this product, the Cloud9.
I drive my F1 to work every day.
Oh, man.
And you get a ticket every day.
That was my 12-year-old dream. But so this has all the same material science that went into the Foot Defender, but this is something someone could wear at home or when they don't need the Foot Defender anymore, or maybe before they even need the Foot Defender. If we could get them ahead of time into something like this, we're going to launch it in a bunch of different colors. And it's just something you could rock around the house really comfortably.
I would totally wear that no matter what.
There you go.
That is just like a super cool looking house shoe.
Wait, what's the
Thanks,
difference between that and clogs?
It's the same architecture, right? The same form factor.
Yeah, it looks very Netherlandsy, right?
Yes,
Right.
but internally, we've got all the same material stack that's inside the foot defender. So that absorbium, those 2 absorbium pucks, there's like, how thick is that insole, Jason? Like 22
30
millimeter. Yeah, 30 millimeter insole. So it literally feels like you're walking on cloud 9. And then the last we developed, so you
Just
build
to be
a
clear,
shoe.
Cloud 9 was a cloud rating system that where the 9th of in the system was a cumulus cloud, which
Very fluffy.
included cumulonimbus clouds, the puffiest of the clouds. So that led to the tradition of saying, I'm on cloud 9, because you don't want to be on cloud 7, because that's like cirrus clouds and other whatever.
That's where angels go to die.
I actually never knew the origin of that. So
No, it was
that's
a
awesome.
It was a
I did,
meteorologist
to be honest.
who went around the world.
Welcome to the
and
show.
he classified cloud types. And it
That's
just so
awesome.
happened that cloud 9 was the cumulus puffy cotton cloud in the sky.
So
Yeah.
Jason, before we have to wrap all of this up, sadly, 130,000 amputations in the US each year. How many do you estimate you could possibly take out of that
Good question.
number with this boot and this footwear?
So imagine if we could get our technology on 10% of that number. Each one of those amputations costs the healthcare system $500,000.
Each one.
Each one.
What?
Ooh.
The price of the amputation isn't for the surgery. It's the prosthetic. It's for the rehab of the patient. Right. It's for
It's for everything.
the health care of that patient. And by the way, the mortality rate at 5 years for these amputated diabetics is 50%.
Damn.
So it's higher than most cancers.
So you go from amputation to 5 years of 50% mortality rate?
Correct.
Oh my good.
So the whole idea behind our business, the whole idea behind the foot defender and its offshoots is stopping that moment of tipping from treating a wound to a mortal amputation.
Right. So can you talk to us about price point? Because it seems as though that might be an important factor. I looked online and there's like crap boots for like $60. And then there's like these super like high tech looking boots for $400 and everything in between.
So we are a approved reimbursable code by insurance. The code is L4361. It pays on average around the country around $295 for reimbursement. So we're selling to doctors and medical distributors. They fix their own prices. Our current retail price is right in the middle of the range you just talked about at $250.
Okay.
Isn't that cheaper than modern Air Jordans? Isn't
Correct.
that cheap?
Pretty much,
Cheaper than
yeah.
a good pair of basketball shoes or
Right.
even running shoes at this point in time.
Yeah.
Mm-hmm.
That is just tremendous on every level. Congratulations, guys.
Yeah, you guys.
Congratulations.
You know, it's possible to put design and science together and try to save the world.
Didn't I tell you at
And
the top, Neil? The Sportiverse try
The
to find a
Sportiverse.
solution to this problem.
Exactly. Well, Michael, Jason, thank you for being guests on StarTalk.
Yeah.
You've enlightened us and you've enlightened our audience. And we look forward to the end of an entire category of amputations because nobody wants to lose any part of their body at any time. All right, so you guys have a website or something where people can dial in on?
Absolutely. Footdefender.com.
Okay, that's clean and simple enough. Excellent. And Michael, do you have like a design page or something where I can just hang out in it and
Yeah,
look at
you
the
can
stuff?
you can just go to michaelditullo.com, or if you're on Instagram, the letter D, the number 2, L-O, DiTullo phonetically.
Okay.
Yeah.
I see what he designed that.
Yeah, I see that.
You even design your own damn name.
Yeah.
All right. All right, guys. And Gary, Chuck, always good to have you there. as my
Always a
co-host.
pleasure.
Pleasure.
I love this topic. And Gary, keep digging up these topics.
Oh, yeah.
This is coming out of your satchel.
Yeah,
so
this,
I love them all.
we've got a production team and we're going to keep mining. And
Yeah, let's
hopefully
keep-
we can find people of this quality and go forward.
Let's keep doing it. All right. Neil deGrasse Tyson here. As always, keep looking up.